of 596A peer review presentations. We have 4 interesting talks scheduled for today, and we'll go in order. The presenter will share their screen and give their presentation, and then I'll remind them at the end when there are questions, if you could read the question in the chat before you answer it, that would be helpful for us to capture not only the question, but the responses. Okay, so first up, we have Isaiah Bashan, who's going to be giving a presentation on Wither the Weeds, GIS database in support of invasive species management planning in Pennsylvania state parks. Isaiah, take it away.
All right, thanks. All right. So as Fritz said, developing for my capstone a GIS database to support the invasive species management in Pennsylvania parks. In fact, you have a background map there from the Department of Conservation and Natural Resources displaying the state parks in Pennsylvania. So, brief overview, go through an introduction, discuss some impacts and importance, the background and lit review, cover my goals and objectives, the anticipated results. I have a notional map, and then a brief timeline, discuss the presentations and references and questions. As you can see, abstract is the goal of this project is going to develop a GIS database to support the Department of Conservation and Natural Resources invasive species management planning, and the database will enable DCNR to synchronize their deliberative HMZ site selection with handheld field data collection in order to generate visualizations of the ongoing remediation activities. So about me, I'm originally from Portland, Oregon. I've been interested and involved in environmental issues such as invasive species since 1995. Did a riparian zone restoration in Mount Hood National Park, led an English ivy remediation in Eugene, and when I lived in Los Angeles, I worked with urban canopy and urban forestry education organization. Currently, I'm a geospatial analyst for the Department of Defense here in Colorado Springs, supporting US Spacecom. Previous to moving to Colorado Springs, I lived in DC, and I was studying environmental resource policy at George Washington. And as the time that I've been in the MGIS program, several of my projects have been focused on invasive plants, specifically in Portland, Oregon, as you can see on the right. So, brief introduction. In 1999, executive order defined what invasive plants were, that they are non-native and to an ecosystem, and that their introduction causes economic or environmental harm or harm to humans. In Pennsylvania, invasive plants have a direct impact, degrading native plant habitats and parks, as well as impacts to public health and livestock and agricultural land. Regardless of where they are, whether it's Oregon or Pennsylvania, or even in Malaysia, invasive plants are frequently introduced to the native ecosystems through human actions. This can be the transportation intentionally of infected plants, seed, garden, nursery, business, boats, and specifically to state parks and forest management, equipment such as logging trucks and excavators can unintentionally bring in the seeds or existing plants in the treads or just through the kind of common activity. Just to note, in the background of each of the next few slides are the pictures are examples of some of the invasive species in Pennsylvania. So this is Japanese stiltgrass. Here our background is kudzu. The impacts that invasive plants have in Pennsylvania parks, there's just a few kind of more notable ones. So like giant hogweed, Japanese stiltgrass, reed canary grass, kudzu, and invasive shrubs like multiflora rose, and then poison hemlock. You can read their impacts. Some of them are very dangerous and unpleasant, like skin blistering and blindness. Others are those are human impacts. Others are just habitat impacts, creating monocultures and kind of outgrowing and outcompeting native plants. Of note to me that I found disturbing was kudzu, which is here in the background, completely can outcompete native plants as we see here, and it does what's called girdling, which the plant will grow around a native woody stem, woody plant like a tree or a shrub, and the girdling will cut off the bark of the native plant almost all the way down to the xylem, which effectively strangles and then will kill the plant above that girdle. So this can result in, not just the weight of the plant, but actually killing native plants will break the branches and topple trees. So in Pennsylvania, the Department of Conservation and Natural Resource performs the invasive plant remediation. DCNR manages 2.2 million acres in Pennsylvania as state forest and 120 state parks. The process DCNR uses is this invasive species management plan, and this plan was developed in conjunction with actually the Penn State College of Agricultural Sciences wildland weed management program. And the process is site specific. It considers the quality of these habitat management zones and the species present. Habitat management zones are effectively the diverse habitat that exist within parks. There are roughly 7 types, and they can include riparian zones, wetland zones, forests, young forests, older forests, and this ISMP process designates these HMZs, assigns a value to define these 3 features: habitat type, stewardship, and outreach. And then that process creates an indice as to where the work site, the most important area to work. Stewardship is the site integrity, like how much disturbance has been in the site. Outreach is how significant that site is to participants and stakeholders, so the public, boaters, hunters, or even state legislature for funding determinations. And habitat is obviously the HMZ or the habitat type in the park. So the thing now is this process is driven through a lot of subject matter expertise, workshops, and Excel, using Excel workbook. There is no GIS application for the assessment portion of the ISMP. Where this becomes a challenge is that the fieldwork portion, which is done by DCNR, does use a GIS, uses ArcGIS collector for field data capture. So the assessment remediation elements cannot digitally interoperate, meaning that there's a lot of basically fat fingering and transferring of information from a workbook to either GIS or from a GIS back to a workbook. So the creation of a database would facilitate the efforts to do invasive species management and enable visualization of those management efforts, kind of the long-term development of the site remediation. So the thing that's interesting is DCNR does have GIS capabilities. As mentioned, that first page was a picture or a map of the state parks. They have a data portal, and there's even map galleries on ArcGIS Online. So my suggested proposal will be to compile a normalized database, GIS database, for the assessment process, and that should allow for quick search and query through a map-based interface and allow for visualization. In this sense, normalization is the way to ensure that a database structure is suitable for querying, and it's free of undesirable anomalies and errors that could cause data integrity loss. So the options are, because the DCNR already uses ESRI software, is that this could be created a ESRI geodatabase. Another option would be to create a database using the free and open source software such as PostgreSQL or PostGIS. I'm more familiar with ESRI, but it's potentially more cost effective and easier, quote unquote, to use the free and open source software, less license cost and maintenance issues associated with ESRI. The scope's going to be limited initially because basically I have to learn how to create geodatabases either in free and open source software or work with ArcGIS administrator and enterprise level solutions. So due to manpower and training and time, but the goal is to create a database that is robust enough and flexible that I could expand it up to the rest of the state parks. So background, as we've discussed briefly, invasive plants, they degrade native habitat, they outcompete native plants. And this is usually because they grow faster, they grow sooner, and because they establish these monocultures where the either other plants or existing wildlife is unable to survive within that monoculture. So like the example here is garlic mustard that destroys native butterflies. So within the pedagogy of GIS and invasive species, there have been many projects that use GIS. However, there haven't been that many that I found that are specifically geared towards database development for habitat invasive species management. Two of the ones listed here, the one by Kullers and the one by Tateyama, those are both other master's degrees, and they actually are very helpful because they develop geodatabases for their specific projects. One of the things that is additionally interesting, or this is what's known as a floristic quality assessment GIS can support. And these are basically a method, biodiversity evaluation that uses coefficients and standardization to calculate the indices that reflect the status or the quality of the native plant community. So this is kind of a tertiary goal for the project, as well as to establish a baseline for DCNR to do floristic quality assessments. There have been several studies that discuss the use of GIS in floristic quality assessments, from in forest biodiversity in Italy, field mapping in Malaysia, and then activities in India. And finally, there was a larger survey done to assess the sampling rigor of GIS floristic quality assessments. So goals of the project are to create a normalized GIS database. It operates on the back end of the ISMP process, and back end, in the sense that front end is what the user can see, back end is the infrastructure built to support the front end activity. And so that would be the server or desktop side of the ISMP process. A secondary goal, as I alluded to, was the integration between the assessment side and the field data collection. And then tertiary would be to create the visualization graphics to depict remediation and to assist with floristic quality activities. Sorry, it's a lot of text, but quickly, the challenge here is right now is the methodology. As noted, the question earlier about what format I would use. The reason is the communication with DCNR and scheduling due to COVID and just schedules has been a little challenging to nail down and to really quantify what specific formats and specific attribution is required. There are going to be continuing discussions with DCNR to identify those attributes. There are other activities and other organizations like the North American Invasive Species Management Association that have data standards. Fortunately, even the Forest Service uses the North American Invasive Species Management data standards. So there's a good resource to use. The challenge, a big challenge I can find regards to the format, is going to be creating the calculations necessary to develop the indices for the site assessments, because in the ISMP workbook, those calculations are performed using macros. So importing an XLMS file format directly into a GIS is a lot more difficult than importing just a plain Excel map. An option would be either to script that import through Python, or develop a database and then use scripting to perform similar similar calculations for the site assessment. So additional review and research is needed. So these are just some examples of methodology and designs. So as I noted earlier, the Tateyama study, she developed a way of prioritizing invasive species in Carlsbad hydrologic unit, and has some great examples of project workflow and system design. And then on the left was a study done by Morgan and Greco, where they developed a GIS database for public gardens. And I think actually that's going to have some good utility in the long run. The anticipated results, as mentioned before, is to create a GIS database. It'll capture the current calculations for the ISMP workbook. And those are examples of that workbook are table 1 and 2 here. And then the desire to create visualizations of site remediation. So the graphic on the right isn't exactly the goal. The goal for those graphics for DCNR is more of a hotspot or heat map. However, this graphic is from a study done in Israel to assess the distribution of invasive acacia trees in coastal Israel. And the kind of the hot spotting in this graphic is similar, though not quite exactly what the goal would be for the DCNR project. So real quick, this is just a notional run through of a park. Very possibly this will be the park that I focus on. This is Nescopec, as you can see in the inset map. It's on the eastern side of the state near Wilkes-Barre. Data, all the vector data for this comes from the DCNR open portal. So the park has roads, trails, and water. The creek, these features, in addition to a map from DCNR state map. I georeferenced the state map to the ArcGIS map, and then created notional HMZs. Now, I don't have the remediation activity for this park, but basically the goal would be to take this kind of data, the HMZs, and to incorporate the field activity within each of those HMZs, and then over time show kind of a stoplight chart, red, green, blue, red, green, yellow of the work done to show how the park has been, how the site has been improved. My timeline is obviously August of this year through hopefully August or so of next year. The two venues, there are two venues that I could potentially present at, which would be, one is the Society for Conservation GIS, their annual conference. That conference was virtual this year. My assumption is it'll probably be virtual next year. And if the schedules remain the same, that means that September of 21 would be the presentation time. Alternatively, I could try and present at the North American Invasive Species Management Conference. Their conference was also virtual this year. Again, it's not unreasonable to assume it'll be virtual next year. And if that's the case, based on the schedule for this year, the presentation would be around October. And these are my references. And if there's any questions, I will stop sharing.
All right, great job, great job. So as Isaiah said, if you have any questions, please type them into the chat. And then Isaiah, please read the question before responding.
Yeah, so David has a question. How sensitive database design is to different use case scales, fieldwork, collector versus overview maps for decision makers. That is a good point. There was one of the studies I read to discuss kind of the challenge of aggregation, reverse aggregation, and that is, I believe, one of the challenges in statistical analysis, the what is it, the modifiable area problem. I think the goal in the long run for the map, specifically for decision makers, will be really just to visualize to them change over time. So it won't necessarily be concerned with, this exact lat long for this bundle of, reed canary grass or kudzu, but more that this portion of the park, which may contain multiple invasive species in it, has been addressed and there's been work done, and we started, say, this year, and as the remediation has gone forward, you can see over the last 2 years, we've done this much change. So there is a kind of aggregation issue, but I think really, again, to the state level decision makers, at least, they just want to see that their money is being spent well, and that there's useful effort being done. So it's a good point to bring up scale. Fritz asked for me to expand a bit on the difference between open source and commercially available data and the impact on database options and the impact on the study. So, for example, the ESRI geodatabase process is, personally, I mean, I've been doing GIS since 2002. Creating a GIS database, a geodatabase in ArcGIS is relatively straightforward to me. However, that's at my desktop for my individual use. The challenge of then scaling a personal geodatabase up into an enterprise geodatabase that can be managed on a server and has web access. Effectively, it's a license issue, cost issue in that case. There is a significant amount of material available to support that. And then, sorry, John Sullivan had another question, I'll get to that. But then the free and open source software, this is all kind of done with the passion. It's not necessarily cost free, but it is free license wise. And there are significant, again, resources for that, including, Geography 868 and in the MGIS, which discusses ways of building both ESRI and free and open source software databases. The challenge, I think, the impact for the database here is the cost of ESRI that DCNR may have to, incorporate. They do have an enterprise license. I don't know that this would necessarily be able to be integrated into that. So I don't want to create too much additional cost for them. But then do they have the ability to support free and open source software, i.e. can they install it, can they run it, do they know how to use it? Free and open source software can be integrated into their existing GIS systems. Those are integratable, so you can go from free and open source up to ESRI. And then, so it's cost versus being able to install and run, I guess, right now. John Sullivan's question is extracting spectral signatures to identify where plants are. Yes, there are many of the studies discuss using remote sensing. I think in this case, we wouldn't necessarily need to do that because there is existing infrastructure, personnel, material, equipment that can do the remediation and be on the ground. So we could theoretically develop a model to assess where in a park additional species would be. But again, I don't think the concern is down to the species level in this case, but it's more the aerial focus. So again, this habitat management zone, this young forest patch that we're working on in this park has 4 different invasive species. We've identified them. We've identified that this zone needs to be worked on, and this is the work we've done. I don't know that we need to identify, really incorporate remote sensing in that case. Neil has a 2-part question. Do field workers need to know the calculated values in the field? So I guess in the sense of like, the crew doing the invasive species, and the second part of the question is there a preference between Python and Model Builder for the calculations? So I'll answer the first part. So in the sense of like, if I am the guy out in say Nescopec Park in the Young Forest area and I'm pulling weeds, do I need to know the calculated values? Not necessarily. I need to know what the species, what invasive species look like, so I know which plants to pull and which plants to, what to work on, so I don't accidentally cut down native plants. But it's more that the field data I'm capturing in Collector and the assessment values done through the workbook process, they can't be merged together easily. So no, the field worker doesn't need to know calculated values. Maybe the team lead for the field work would need to know that, or need to know the site work list, which is derived from the values. And then to answer the second part of the question, preference between Python and Model Builder. No, I don't think there's a preference. The preference actually would be whatever's easier, honestly. Again, so through the MGIS and Geography 585, did some ArcPy work, ArcPython. That's very robust and it can do really great work on calculations that's relatively easy to run. However, you have to know how to use Python and have staff that can run it. So if Model Builder is easier, to just kind of click that button and run the calculations. Again, that does kind of come back to the challenge or the question about what format DCNR prefers to have. And if their enterprise license does allow for server or kind of enterprise database management, then using ESRI's software and ESRI's formats is probably the easiest. But I have becoming more of an adherent or a advocate for free and open source. So I can see the utility of using that, but no, I don't think there's a real difference between Python and Model Builder.
All right. Let's move on. Isaiah, great job.
Thank you.
Thanks for all the questions. And up next, we'll have John Sullivan. And the topic of his title will be how have the spatial patterns of wildfire perimeters and the wildland-urban interface in Oregon and Washington State shifted through time? When you're ready, John, go ahead.
Okay, can you see my screen?
Yes, we can.
Okay, so wildfire perimeters, it's a big topic nowadays, especially in California. With me, I'm living in Washington State right now. I'm in the Army, I'm stationed here. I've been in the Army 17 years. I'm a geospatial engineer, warrant officer, so I do a lot of terrain analysis. I'm more the engineer side, but we kind of delve into the intel side with, that's why I brought up the remote sensing thing. But that's not really my discussion here. Here, I'm taking kind of like a statistical analysis approach of, maybe over the last like 3 to 4 decades of wildfire perimeters and how they've meshed to show patterns with the wildland urban interface, commonly referred to as the WUI, in Oregon and Washington State. Initially, I was going to do just Washington State, but just recently, talking with my advisor, Dr. Erica Smithwick, we're going to include Oregon as well to give myself more data, and also a lot of, everything shifting further north. California is pretty much on fire, and now Oregon's becoming on fire, and soon Washington State will probably follow. So we got to look at what's going on in Oregon to kind of see how Washington State might have to prepare in the future. So moving on. So the purpose of the study is to demonstrate through spatial and temporal analysis how thousands of people in Oregon and Washington State are moving into the WUI, becoming more vulnerable to wildfires. By identifying vulnerable areas, we can help Washington and Oregon State firefighters allocate time and resources to a given region. They can get more manpower, or we can simply educate people on the risks of moving into these areas, because there are techniques available to prepare your house or fight fires, or just keep your possessions from burning. And you can also have a plan for you have to move out, or those numerous factors. It's not just, it's more economic. It's a social economical issue as well, because urban areas are becoming costly to live in. So it's not just wealthy people building houses out in beautiful areas. It's trailer parks. As we recently saw in Oregon, whole trailer parks are blowing up, and a lot of those people don't have anything to go to from there, and insurance really isn't in a place to cover them at the moment. So they don't even provide insurance. So it's another aspect I'll get into. So my primary goal is to determine like if the trends are disproportionate by quantifying how it has changed over time. And the census data is big in this. So I kind of wish I had the 2020 census data, depending on if it's going to be good or not. It's still questionable. So I'm gonna have to rely on census data from 2010 and before. But I'll have to follow. We can kind of assume that more people are going to the WUI. Over the past 10 years, and may or not have doubled. But we can assume that a lot more people are moving into the WUI when I establish that trend. So looking at the background, climate change is causing the Earth to warm faster than we anticipated, and it's brought larger and more frequent fires to our forested ecosystems of Western North America. This trend continues today with fires burning longer and hotter. As we've seen over the past few months, Washington State this past summer lost more land acreage to wildfires than it did in the previous 15 years, according to the Governor Inslee. And I haven't really looked totally at Oregon, but I could assume the same thing has happened in Oregon. So let me just give a little background on what the WUI is. It's a regional classification, categorization using U.S. Census and USGS national land cover data to determine people living in relation to wildland vegetation. The fact that we have more people building houses in these regions is causing environmental concerns such as wildfires, goes into the habitat fragmentation and invasive species and biodiversity decline. Because as people move into these areas, they do introduce invasive species, and they mess the terrain up pretty much. So for this study's purpose, I'm focusing on the wildland fire factor and how through time people are becoming more vulnerable to its destruction by looking at certain factors, such as the areas where the houses meet or intermingle with undeveloped wildland vegetation, focus area for human environment conflicts such as wildfires, habitat infringement, and then integrating the census data to map the federal registration definition of a WUI and how, statistically social economic classes are vulnerable to certain, certain wildfires. So, getting data sets for wildfires, DNR seems to be the leading person for Washington State, whereas Bureau of Land Management seems to be the leading person for Oregon. I'm not quite sure why that is, but doing my literature review and looking through different data sets, that's just kind of what I found. So I still have to merge the data sets to identify, to kind of, with attribution, doing joins and merges to get a true, one layer to analyze for a fire perimeter. But roughly, we can estimate about 1,000 fires in Oregon State and Washington have occurred over the past like 50 years. But that's large wildfires. That's like a large wildfire is categorized as something that burns 100 acres or greater and 300 acres or greater in grasslands and rangelands. So it's not just normal fires, it's actually like huge fires that have displaced personnel and burned a lot of vegetation. Washington State alone, there was 549 between 1979 and 1919. This topic is of particular interest to me because I live in Olympia, Washington, and I've never really lived on the West Coast and seen a wildfire, but this past month or two, we had some of the worst air quality in the world, really, because of some of the fires burning around Portland and even in Washington State. So it's dangerous, really, and I wasn't even anywhere close to these fires, and like I didn't even know why my pet wasn't going outside, until I found out pets are pretty smart, and they won't even go outside because the air quality is so bad. I thought my neighbor was like having a picnic or something, and no, it was a fire burning hundreds of miles away. So it's more dangerous than people think, and unless you've actually been in one and seen one or know of people, which it's going to get worse too. So it needs to be more looked at, and California is kind of a mess when it comes to socioeconomic people moving into the WUI. It's worse down there than it is in Oregon or Washington. But for this analysis, I left California out to save myself some time. These forests are beautiful too. Like that's why people, it's probably why Microsoft stays in Seattle, is because Mount Rainier, the Cascades are a beautiful place, and same with Oregon, the Mount Hood area. People love the recreation that surrounds it, and I don't think people are going to want to live here if there were no forests. And we're not really. I think there's other factors that lead into why. I'm not really getting into the factors of why the fires burned, whether or not it's arson or just fuel that's built up over hundreds of years or decades. It's more or less just kind of educating the people that move into these areas on the risks associated with why they're moving there. So looking at my scope, so taking the WUI, here you can see the WUI polygon for Washington State. I haven't, so I kind of just looked at just because I added Oregon just recently within the last week. I wasn't able to go in and actually totally do what I did for Washington State. But here you can see the WUI. I identified certain career criteria from it. The WUI polygons was provided by Silvis Lab. It's recategorized which populations are in vulnerable areas. The WUI layer is organized with census results from 1990, 2000, and 2010. The attribution fields I used to categorize which census blocks are at risk are based on the parameters you can see in the slide. Just high density housing densities, 741 houses per square kilometer. Just generally in the urban areas, those people, generally aren't at risk. It's the medium to low densities where you kind of get into the wildland urban phase, and then how those intermix with wildland vegetation greater than 50%, but also interface with being 2 kilometers away from an area that has greater or less or equal to 50% wildland vegetation, because we can assume if you're 2 kilometers from a large forest fire, you will be affected somehow. Not just for being displaced, but your property will get damaged. Sometimes the heat can burn houses, and a lot's being made to. It's a cost issue. People that do move into the WUI are starting to build their houses more fire resistant, but that's costly and not always feasible. Wood is still the preferred method to build a house. So I use this method because I'd like to take into consideration low to high housing densities that are intermixed short vegetation that are intermixed with the wildlife vegetation. And I just came up with that criteria based on the attribution from looking at the data. And then after I did that, you can see from the slide, it does kind of paint a picture of the red areas are the newer areas, white areas are older, yellows, 2000. So if we did have the data from 2020, you can assume that it'll just be more houses. And the Spokane area and Yakima in particular are at risk as they're further east. They don't really get the wet weather that we get on the west side of Washington, but even that is there's been a few forest fires out in the Olympic Mountains, which is one of the wettest regions in the nation. So just the fact, if the summers here are getting pretty hot and they're getting longer, so the western portion of Washington is at risk, and those mountains are far more lush and dense. So once those fires start creeping west, then people are really going to have a problem in the greater Tacoma, Portland, Seattle regions, Olympia. Next slide. So for this, I used, this is Washington State again. You can see the National Interagency Fire Center, the NIFIC, is what I use for the Washington State Fire Perimeter, as you see in yellow. Those are all the fire perimeters from 1973 to 2019. So you can just tell just by looking at the fire perimeters that, yeah, they're primarily in the eastern portions due to drier climates, but they are starting to creep west. And even people, because Seattle is becoming more populated, people are starting to creep more to the eastern slopes and, commuting into Seattle or building, more infrastructure out in Yakima or the Tri-Cities area or even Spokane. So, yeah, I'll have to apply statistics from Oregon. I haven't really looked too much at Oregon. It's more Washington State. But you can see in the graph at the bottom left, it's definitely an upward trend with acres burned and, fire severity. So these layers are crucial to analysis because it helps me identify the spatial trends of where the WUI and the wildfires meet based on what's previously happened. Another source of information was the U.S. Census Bureau, getting into their data sets, looking at the block 10 layers, which the census blocks, organized from state, county, tract, and block. So going down to the smallest, scale, I would generally, use the block. The block is defined as the smallest geographic area for which the Bureau of the Census collects and tabulates census data, and are formed by, they generally formed by streets, roads, railroads, streams, or other bodies of water, other than or other visible and cultural features. And they are legal boundaries under the U.S. Census Bureau. So that's generally, and then they come with their own statistics of income level and just number of people living in households. I didn't really think about how going into the whole problems with this census. I didn't really understand the problem until I started looking into analysis, and this is just one aspect of why we need accurate census data. If we're going to actually help people. And so it gave me, more insight into how big the census is. So the U.S. Census Tiger block polygons are associated with housing and population densities, while the WUI dataset incorporates spatial joins with these housing datasets. So the WUI does take into consideration where people are already living when they identify what is the wildland urban interface. I'm more or less going to show through time how that's changed and apply some statistics to it to educate people primarily. This is all new to me. The fire data also contains contains attributes for how fires started. So I can't incorporate different factors leading to a fire's cause. I believe the recent ones in Portland were primarily arson, which, if we continue to go down the path we're going, more destruction from, anarchists or larceny may come into play, or even the one in California started from it was a gender reveal party or something. So as people get dumber, or and our vegetation is more vulnerable, the destruction from a large forest fire will have drastic effects. So incorporating that data into analysis, I think is good, because whereas I think most of them are started by lightning in Washington, others could come into play with arson. Um, so, and also how fire's proximity or people's. The movie does look at how far people are from water sources when they categorize it. I guess because they categorize the WUI to give people federal aid. That's why it's important. If you're in an area deemed hot for wildfires or prone to wildfires, you'll get more federal aid, and people will probably come help you. I think that's the whole purpose of the WUI. But I'd also like to look at how close these people are to resources or to fire stations, just to kind of add some more statistics to the analysis. So look at my main objectives. Identify areas where the WUI and previous large forest fires merged, looking at precursors to why those fires occurred for education purposes. Spatially summarize the area and distance to the wildfire urban interface, just kind of tell how close people really are. I feel like if you're within 20 miles of where large forest fires are prone to happen, that's pretty close. But I'll just provide some statistics on why and how certain people are more vulnerable from previous burn incidents, and just quantifying that over time to show how disproportionate it really is the main goal. I think I can see myself creating multiple temporal thematic graphics, not just one graphic, but kind of focusing in on certain areas up and down the Cascade Range. And, I'm saying 10 thematic maps, but it'd probably be more like 20. I have a goal to just create a robust story map or something that people can use, for education purposes, maybe a cascade, or even, there's multiple story maps I could create, but haven't really gotten to that yet. But, once I have all the data organized, I believe one of the final outcomes would be a robust story map detailing, how the data sets correlate and have changed over time, like a time slider as well. So incorporating the census data and analysis based on the block IDs. It's going to be a lot of joining and merging of the data sets. And then also incorporating stories of recently, I was reading this one story of how like a whole mobile home park outside Portland was destroyed, and what happens to those people? A lot of those people don't have anywhere to go. If the time permits, identifying insurance maps and overlaying that will give value added to the study, because insurance companies really aren't providing a cost-effective way for people to get fire insurance, mostly because of the total destruction that comes from a fire. I think they're kind of not being quick about getting people help. So looking at my methodology. So first, I'd like to summarize the available data sets to determine what attribution needs to be incorporated into the proximity analysis. So this would come from the WUI data set, the Block 10 census data, and annual income levels. Understand the income levels of who's considered most vulnerable will bring attention to those who may or may not have fire insurance. Now, a lot of people don't. Just looking at a few studies I've read, as I said before, the cost of living in Seattle and Portland metropolitan areas is driving people into the WUI. So this will cause emergency management and aid concerns when states have to deal with thousands of displaced persons following a major fire incident. Because those can go on for, it can go on for weeks with the smoke and everything and just getting people in safe conditions. I haven't really looked at like what FEMA has done with in relation to Katrina or hurricanes on the East Coast, but I imagine it'll be a similar response. Um, but being the West Coast and the political aid hasn't really come to California as much as some places in Louisiana or North Carolina. So once the data has been analyzed to determine all the associated codes and numeric values to understand the census data, I'll apply the joins and merges to the attribution. And I'll also use the Tiger line, block 10, and WUI classes 90, 2000, 2010 as a fire perimeter layers. I'd also possibly, once I get the data, converting polygons to rasters, doing algebra calculations, do like cost distance analysis. I haven't really identified a criteria I would use just yet, but possibly doing cost distance analysis from vulnerable locations to resources would also aid in the study as well. So to go on, after I've concluded spatial or statistical analysis to determine how vulnerable certain populations are, I'd like to do the cost distance analysis from fire perimeter to firefighting resources, such and even locations to water, determine how people are fighting fires. A lot of times, I know here at JBLM, we mobilized, our combat aviation brigade squadrons, the Blackhawks, were mobilized to go help fight fires. I guess they carry large sums of water, so like refilling those water sources. I'll look at how close people are to water sources to help distinguish fires or even evacuate people. I'm going to avoid looking at identifying evacuation routes because that appears to be a whole nother study. That could probably be a study in itself, is determining the best evacuation routes. But I know when you're living in the WUI, they do come out there and build certain fire breaks so that you can run down a fire break or something should you have to. And the last step will be to develop the thematic maps and to add the good, or the bad news stories to establish trends across time of how, it's just in the past 10 or so years that people really started looking at this as they've started getting burning hotter and longer. And it's not showing any signs of letting up as, our Earth continues to warm. It's not rocket science to, if we look at what Arizona and Southern California look like, we can assume that's going to creep north. But there's certain areas like Lake Tahoe that nobody wants to burn up that are probably more vulnerable than Oregon or Washington, but we still need to look at that. And if times allows, and it probably will, I'd like to just narrow the scope to like 2 or 3 hotspots around, probably Portland area and then like the Yakima area, just to determine. And I wanted to kind of do like a feature extraction from land cover data sets, like from more recent, just to kind of really determine how much it's changed, how much the urban environment has moved, has shifted. So if times allows, I like to pick two areas and kind of just show how more people have moved into vulnerable areas. There's also land fire data sets that add the forest type, the fuel type, the fire regime, topology and climate of certain areas. I'd like to just incorporate statistics from those, just to kind of determine, what types of forests and fuels are really burning up in the forest. and demonstrating the true powers of web-based GIS and for education purposes, I believe a great story map will really aid the analysis. So here's a list of my data sets. Syllabus Lab has the WUI and the growth in housing densities in the US, have the census data, Department of Natural Resources, or Department of Resource Fire Statistics, and then the Bureau of Land Management, Land Fire, and OpenStreetMap for the water resources and fire station locations, and then administrative data sets from Open Geospatial portals for Washington and Oregon. So some of my challenges and limitations. The census data does not entirely depict where people are living in regions where humans meet nature. You know, the census data is never accurate. It's it's best I don't really know how to put it, but like, you know, it doesn't often depict exactly who's living in certain areas. So in the 2020 data is not going to be available in time for me to do this analysis. It may or may not be accurate. Fires are burning as we speak. So it seems like, you know, the wet season's come. So I don't think there's going to be any more large fires this year, but, you know, incorporating what's occurred into my polygon perimeters may not be, I'm pretty sure I'll be able to figure that out and actually apply it to my analysis. And there's not enough public knowledge or support to drastically change how we live, to mitigate the damage that this is causing. So it seems plenty of data analysis is out there to summarize now, but it, you know, gathering pretty much maybe a limitation on or may not. I mean, yeah, there's not many limitations, I would say. I think I got enough resources and studies out there to properly conduct this analysis. My expected results. So I expect the study to demonstrate how more people in Washington and Oregon State are moving into the WUI, leaving them more prone to ultimate destruction caused by large forest fires. I expect to establish a quantifiable trend on how people in Oregon and Washington State are moving into these areas. The study will show how Oregon and Washington State can do more to ensure citizens living in vulnerable regions are prepared with insurance or other protective measures to ensure lives and valuable property is not lost. This will also demonstrate how people are moving into these vulnerable areas with statistics and graphics to back it up. So here's my timeline. I just had a baby, so I got a three-week-old baby. So I'm taking a break after this until like the end of Christmas. So I think I'll do 596 Bravo in January, and I also have one more class to complete the program. So I assume I'll be done early March or late March, and not sure where I'm going to present it just yet. So that concludes my brief. Any questions?
Yeah, we have time for one question.
I can't. I'm trying to bring up my chat. Sorry. All right, I'm trying to stop sharing my screen. Okay, sorry. As one who has evacuated the El Dorado fire earlier this fire season, I thank you for taking on support and timely topics, since public outreach is our ultimate goal. I have given thought to how you will promote your story map to get it noticed, and then how you will assess its impact. I hope you will consider this as part of your project. So, I guess, yeah, good point. You know, I live in Washington, and one of my next door neighbors works for Governor Inslee. He does more disaster management for oils. So You know, I'm in the Army. I got generals here. I'll share it with the commander of Joint Base, Lewis McCord, and I guarantee you, Governor Inslee will see it. I don't know. I don't know how much else I could do. I hope you'll see it. I don't know, but yeah, I mean, this is a important topic, and I can with that, 80% confidence say I can get this in front of the governor. I don't know about Portland though. Yeah, I can, social media. I can. I guess Penn State probably has a. I might need help with that actually. I have an Instagram, but I have like 30 followers. So. But yeah, I haven't really thought about social media. That might be a question for the faculty.
Hi, this is Erica. Yeah, I would just chime in to say that the Joint Fire Sciences program has a fire exchange network or fire science exchange network, which is meant to communicate results to managers or policymakers. So that would be a great place to share the results of this work.
Thanks, Erica. Thanks for coming too.
Thanks for doing all the work.
All right, we're trying to get the next presenter lined up here. So again, John, thank you for your talk. It was very, very informative. Next up, we have Fernando Galindo Garcia. If you want to go ahead and start sharing your screen, Fernando, I'll introduce your talk. The title of Fernando's talk is Evaluation of Fog-Based Dust Control Measures in an Open Pit Mine Operation through Air Mod Dispersion Modeling. So Fernando, whenever you get your screen shared, you can go ahead and start presenting.
Fernando, we don't hear you, so make sure you're not muted. Fernando, can you try leaving the room and coming back in? It looks like you're in the participants list twice, so maybe make sure you close all your windows and try coming back in because we don't hear you.
Hello, can you hear me, Beth?
Oh, there you are.
And now if you can click, oh, there you go. Great.
Hello, everybody. I'm apologize because I missed the last sessions. I got confused about the timing. Well, I understand I have 20 minutes. This is Fernando Galindo Garcia. I will present my work is called Evaluation of Fog-Based Dust Control Measures in an Open Pit Mine Operations through Air Mode Dispersion Modeling. The air pollution is the discharge of any harmful pollutants into the atmosphere, affecting human health and the environment. These pollutants are known to be responsible for several severe health problems. The TSP, or total suspended particles, is a measure of the mass concentration of particulate matter, or PM, in the air. There are three fractions of this TSP. The inhalable fraction that can enter into the throat is the upper one. The thoracic fraction that can pass the bronchus, and the respirable fraction. This can reach the alveoli in the lung. The Environment Protection Agency has found that 50 micrograms per cubic meter increase in 24-hour average of PM10 concentration will result in 2.5 to 8.5 increase in mortality rates in general public. The dispersion of these suspended particles depends on the weight of the particle and on the flow of air on the particle. Mostly, the mining activity produces particulate matter, which are this is a major threat to the environment once it becomes airborne. The air pollution is one of the major issues associated with the open pit mining, and there are environmental, health, economic, and political impacts. This figure depicts the Timmins study case. It is a 100 years operation inside of a small city. As you can see, there are houses located within the Hollinger open pit within the blasting safety radius. I think less than 200 meters. The PM, the particulate matter, is released by the mining operations during the open pit operation. There are three major phases. There is the blasting, the haulage in paved roads, the loading and stockpiling of material. And these three phases can be accountable for the 78 to 97% of the total dust emission of PM10 in any open pit mining. How to measure these impacts? Well, you need to use direct monitoring through sensors, mainly through sensors. And you can use dispersion models for predicting these impacts. These dispersion models needs to consider the meteorological and meteorological conditions of the pit for taking in account all the complexity of the terrain, and it has a heavy influence over the emission behavior. You need to consider the actual flow and dispersion characteristics, and by using Gaussian plume dispersion modeling, you can have the emission paths over the pit. For the model selections, you need to consider the terrain complexity, the dimensions of the pit and of your areas, the particle sources, and a major challenge for modeling the dispersion of fugitive dust emissions from deep surface mines is the influence of the in-pit meteorology. One of the models that take into account all these factors is the air mode dispersion model. This dispersion model in its 2005 version is the recommended one by the US EPA for assessing pollutant dispersion in complex terrain conditions. It has two main major inputs. There is the terrain and receptor data in a model called AirMap, and the AirMet model that integrates the emission factors. Those are representative values of the emission calculated by the EPA, the methodology, and the monitoring, the real results. By using these two inputs, you have profiles and that result in concentration measures. This air modeling system has been validated for predicting fugitive dust in open mining operations. In this figure is the NIOSH hierarchy of controls approach. It consists in 5 control levels, from the most effective to the least effective. And you can eliminate or remove the hazardous substance. You can substitute or replace with a less hazardous alternative. You can reduce the exposure of your people, in this case, or your control via engineering controls. You can provide administrative controls for minimize exposure risks. And the last frontier is to use the personal protective equipment, or PPE. This is a major problem for mining industry because the actual dust control methods are estimated to reduce only the 25 to 50% of the respirable size dust that they generate. The objectives of this study is to model the parameters for dust control measures based on fog cannons in an open pit operation. This objective is composed by these specific aims. First one is to update the emission inventory for PM 2.5 and PM 10 fractions. Then to apply this air model for predicting these PM emissions. To evaluate the impact of fog cannon parameters over these PM emissions. And last, to predict and validate the fog cannon influence, this control, over the PM general emissions. The study area is a polymetallic mine in the northern part of Mexico. It has two open pits, 3 major waste rock dumps. It has 1 concentrator plant, heap leach, a metal coke plant, and all the accessory conveying systems, access roads, storage, energy, offices. There is a camp for 5,500 people and transportation facilities. The air mode view software that will be used in its version 9.9 has three major inputs. The first one is the monitoring network, the PM monitoring network, that together with the emission factors will be used to generate an annual emission inventory. The second one is the meteorology data. We will have wind and temperature parameters. And the third one is physical parameters. This model takes in account the topography, the surface complexity, and all the buildings and the current or most approximated land use. The first one, the monitoring, is made by using two main sensors, the BAM 1020, that is a beta ray monitor. It is used for internal control in the mine. It has low accuracy, but is automated and you can have real-time data. And in the right, the image, the picture in the right, you have the TISH volumetric flow control sample. And it is required by the law in Mexico. It is mobile. You have higher accuracy, but it's manual data collection. And you need to test the results of this sensor, and it is costly. The values obtained by the beta right and the left are contrasted and corrected by the values of the gravimetric monitors. This monitor network is the first data source for the yearly update of the mine emission inventory. And all the sources are identified and classified according to the air mode specification for being integrated into the model. The meteorology data. 4 Campbell weather stations are going to be used to get meteorological conditions. There is an internal database with 5-year collection period. This database can be accessed through a web platform. We have an API for getting this data together with another algorithm or something. The principal meteorological parameters are the solar radiation, wind speed, and direction, and temperature levels. The second module is the physical one. And there is a real-time PITS LiDAR network, an infrastructure and buildings database that is registered by a drone fleet every month, and an annual LiDAR general survey for all the mine. The products are a digital elevation model and land use maps. This high resolution data is used to obtain solid land use parameters. The analysis process is start with the air minute and air surface model. There, it processes the turbulence and stability parameters, and those are sent to the air mode processor with together with the air map output that processes topographic data. This topographic data integrates the receptor and source locations for the study areas. This air mode processor generates the air quality reports and the dispersion maps. And these dispersion maps will be integrated into an impact zones, which in turn will be the basis for locating the control measures, in this case, the fog cannons or the wire cannons. For the visualization, 4 receptor grids will be used for evaluating and visualizing the generated plume. 250 meters, 500 meters, 1,000 and 2,000 meters, parting from the main from the center of the main pit. During the update of the 2019 emission inventory, 39 control measures were identified. These measures are composed by collectors, filters, some suppressants, or their combination. And the equipment for this study will be a wire cannon equipped with an axial fan with a capacity of 500 to 800 cubic meters per minute, and a working pressure of 500 millimeters of wire column. This installation can be fixed on a platform or can be on a special vehicle. Well, if that vehicle has a wire tank, pressure pump, even you can use an automated rotation system. The location and operation parameters of the wire cannons will be obtained by using the impact zones detected by the air mode model in the last step. The result, the wind characterization was made by using the AirMed model. In the figure on the left, the 2019 results are displayed. The predominant direction is southeast to northwest. This is included into the receptors map for generating wind influence maps, like the one in this picture on the right. The emission inventory is classified according to the type of the source, like point, surface, volumetric types, and it includes the EPA emission factors for each activity, like chimneys, the pits or movements, mileage, and those values are corrected by the monitoring ones. As a result of the emission inventory analysis, there are 150 emission sources that can be integrated into the model. By merging the simulated receptors and the monitored values, the concentrations of the model are validated. The model obtained values are shown in the left, the indicator, for specific receptors. These results allow to compare against the regular. They are also allowed you to compare against the regulated values regarding the maximum concentration. Then, according with the emission classification, the PM can be divided regarding its proportion and emitted amount in tons per year, as you can see in the right. Then it's tons per year and maximum concentration. Well, these preliminary results show that there is a trend starting from the emission sources to the northwest to the operation. Those values are within the allowed limits by the law. However, the highest populated community in the north of Zacatecas is the campsite of the mine. And the campsite of the mine is located within the 75 boundary. And because of this, further controls should be applied for protecting this area. The results are useful for designing and planning the location of water cannons around the major dose contributions.
All right, thank you, Fernando.
Thank you.
We have some time for questions. And Fernando, if the questions as they come across the chat, if you could read them before you respond, that'd be great.
Well, I have a question from Fritz. Will your plume visualization take in account the different particulate matter sizes and how far each could travel? Yes, yes, they are taken into account because the emission factors are different for PM 2.5 and PM 2.10. Sorry. And you have a direct survey or measure of the particulate matter. Another question from Fritz is what sort of broader impacts do you think will be possible based on your research? Well, although the fog cannons are used broadly in mining, there are not solid evidence of their impact, positive or negative. And when you project to use them and you put some budget behind them, you can have a solid recommendation, scientific recommendation for locating them. They only use wind direction, and that's all.
Does anyone have other questions for Fernando? Well, great job with your presentation, Fernando. If
Thank
you
you.
would like
Thank
to
you.
stop sharing your screen, and Karen, if you would like to start sharing your screen. Next up, we have Karen Atkins, who will be giving her talk today on WebGIS for recovery of lost archaeological artifacts. Karen, it's all yours.
Thank you. Hi, I'm Karen Atkins, and my capstone project proposal is a WebGIS for recovery of lost archaeological artifacts. Jim Detweiler is my advisor, and I'd like to thank Jim for his support and guidance on this proposal. I'll start with a brief introduction about myself. Then I will present background information, followed by objectives and methodology. I'll wrap up with challenges and limitations and anticipated results. In my day job, I serve as the Senior Hydrography Project Lead for the U.S. Geological Survey National Geospatial Technical Operations Center, or for an easier acronym, the USGS NGTOC. I provide project and program management for USGS National Hydrography, which encompasses the hydrography data sets available through the national map. So why did I choose this topic? I've always enjoyed exploring Colorado's parks, and some of my favorites are historically themed, such as Mesa Verde National Park and Hovenweek National Monument. Archaeological discoveries using geospatial technology such as LiDAR has made the news in recent years, as has news about the looting of archaeological sites for valuable artifacts. I've learned that the problem of illegal artifact collecting is one of great importance from a historic and cultural perspective. So first, I'll give some background on the problem of the theft of archaeological artifacts. Illegal trade in artifacts and other cultural objects has been a problem for many years. The United Nations Educational, Scientific, and Cultural Organization, UNESCO, in 1970 developed the International Treaty to fight the issue of trade in artifacts and cultural objects, which was fueling the trade in drugs and weapons. To date, 140 member nations have ratified the treaty. In the US, laws have been developed and resources have been allocated to enforce those laws. The Archaeological Resources Protection Act, ARPA, protects archaeological sites and makes collecting of artifacts on public lands illegal. And the Native American Graves Protection and Repatriation Act, NAGPRA, protects Native American graves from illegal looting and destruction. Violation of these laws can result in stiff fines and jail time for offenders. But people still commit these crimes. People are fascinated with the past, and collectors seek rare and beautiful objects to add to their collections. And often artifacts are taken with the intent to sell in order to fund other illegal activities. This image shows a vast collection of an amateur archaeologist whose home was raided by the FBI in 2014 for possessing illegally obtained artifacts and bones from Native American graves. Many of the 42,000 plus artifacts in this collection were found to be illegally obtained, and the FBI is still working to return or repatriate some of the artifacts. These images are examples of how looters don't just take loose objects, but also artifacts such as these wall carvings in a Mexico site. As you can see, the looting and taking of artifacts can be very destructive to sites. What I have come to learn is that the loss of artifacts from sites is a loss of historical meaning or context of the artifact and the place where it came from. This quote from Judith Benderson, former attorney for the Executive Office of U.S. Attorneys and who dealt with cultural law, stresses the importance of the historical context of artifacts and how the meaning of the item is lost when it's separated from its origin. As she says here, some collectors do not understand the moral, historical, and scientific implications of separating an item from where it was found. And the piece of the historical and cultural puzzle that it would have provided is likely gone forever. And when human remains are involved, the spiritual link is disturbed. So in the effort to combat illegal trade, cultural theft databases have been developed by organizations including Interpol and the FBI. These public databases are called stolen art databases, as they include many cultural items, such as artifacts, artwork, recordings, and other items. Visitors to these sites can perform text-based searches, but these databases don't provide spatial context for searches and offer limited mechanisms for reporting sightings of stolen objects beyond directing visitors to contact the organizations via phone or email. The information in the database comes from police reports, and users of these databases are most often traders in antiquities and insurers performing due diligence on items. Recovery of stolen items is a challenge, and reported recovery rates are pretty low, usually well under 10%. This is the web interface for the Interpol database. As you can see, searches can be performed as text queries to locate objects. Public archaeological databases can provide a wealth of information, but these databases are designed to share research and historical information. Users of these databases are primarily archaeologists, teachers, and researchers. These databases do not publicize lost and stolen artifacts. And in my research, I found only one organization with a list of artifacts stolen from a state museum on the website. This is the interface of the Digital Archaeological Record, also known as TDAR. It is a little more user-friendly than the Interpol database, and it has search controls and an option to search by geographic region. Summary information is returned, and the user can delve deeper into that information. This is the interface of the Digital Index of North American Archaeology, or DINA. Recent improvements to DINA include a selectable map interface. Tabular records are returned for searches, and the user can delve into more information about the research, culture, and other details of the record. So in reviewing these databases, it caused me to think about how to build a better system for reporting and tracking lost artifacts. In my literature review, the main shortcomings of theft databases centered around limitations of text-based searches, lack of linkages and shared objectives between theft and archaeology databases, and the lack of public sourcing for information that can help aid in recovery of stolen items. I have three primary objectives for this project. First is to create a GIS database to store and share information about stolen artifacts, reported sightings, and recovered artifacts that can be accessed through a web platform for mapping and analysis. Second, I want to engage and encourage the public to become involved in artifact recovery through a web-accessible map application. Lastly, I want to enable visualization of sightings and recovery of artifacts in a web platform. I believe employing a cloud-based collaborative web GIS system will help achieve these objectives. This diagram envisions how really demonstrates how I envision the system. The approach for this project is using Esri's ArcGIS Enterprise and ArcGIS Online. And I'm choosing to work with the Esri Cloud platform because it really offers a full range of configurable web maps, tools, and applications that can be shared within or outside of an organization. So the database for my project will be created using ArcGIS Pro. I plan to include feature classes that will contain generalized location data for archaeological sites, locations of public collections such as museums, and user report locations. Note that archaeological site locations are considered sensitive and require protection from looters, which is why the generalized locations will be created. Tables will be created to store reference information about submitted artifacts and associated images. I plan to use unique identifiers for artifacts, users, submitted reports, and any original identifiers from artifact submissions can be maintained for reference back to any of those origin databases. The data will be published to ArcGIS Online as web layers, and the layers will be used to create web apps that will be incorporated into the web apps used to populate and maintain the data. I plan to create web applications for two types of users using ArcGIS Web App Builder. First is the content submitter, who will have the needs and who will need to have the ability to add and edit information about stolen artifacts and upload images associated with these artifacts. The second type of user is a reviewer, reporter type user who will review information about artifacts and report any sightings of stolen artifacts. This user could be an amateur archaeologist, collector, or anyone else interested in the recovery of artifacts. So I'm going to just walk through a comparison before I get into the web app that I'm going to be creating. This process is what I use to gain access to the Interpol Stolen Works of Art database. It's a public database, but you do need to request access to it. I had to submit the request through a website and then fill out a form that was sent to me. go back and forth with the organization before I could get access. So it took a little while to accomplish this process, several weeks in fact. And this is a simple use case for the interval database. The user has to navigate to the database after logging in and has 3 choices to search the database. They browse a list of over 50,000 items. That's one option. The second option is to perform a custom search by filling out fields, populating those from a catalog. And third option to upload an image that can take advantage of an image recognition search and against the database. Once you find an item to view, you can view it, download a PDF. There's an option when you're viewing the item to send a signal, which is really a very brief text message about the item. So while the database and web interface are robust, it is primarily text-based and really lacks that geographic component. So this is a simple use case for the new web application. This approach improves the experience of the user by taking the user to the application upon login and providing intuitive choices when searching for information. The workflow is simplified and it guides the user through using the application, and the basis of the application is that geographic component. So this is a very basic wireframe of the web app that the reporter or reviewer will use. Various configurations are available for web apps. This one represents a foldable configuration. I intend to design the design to be simple with controls that are really easy to understand. So the first selection on the application is to explore. When the user clicks on the explore button, it will open up a panel that will provide a drop down of existing collections in the database. So the user, and once the user picks a collection, then that will take the user to that location on the map, and the user can then select and review a list of items that are within that collection and view those items. The next option on the application is find, and that would be a more of a search oriented, trying to find a specific type of artifact. So the panel will open up to present categories of items, and the user will be able to select a category and find a list of items and then choose what item they want to view. They can learn more information about that item, and from there, they can also report a sighting. And then the third option is to report, and this will bring up a form. The form is fillable, but if it's jumping from a previous item, my intent is to have information about that item auto-populated, make it easier for the user to focus on where they actually found the item or saw it, and be able to identify by location and date that information that needs to go into the form. So the sighting location can be drawn on the map. They can also do a search for an address, or if they saw it online, they can populate the location as a URL. And additional information can be added to this form. This is really just representing some of the basic information that I'd like to include. So once that information is ready, it's submitted, and the user is thanked for their submission, and they agree to be contacted if needed about the report. And then the last item is learn. To keep the user engaged, it's important to encourage the user to learn. And so this will bring up a panel with information about the project specifically, and the opportunity to learn more about the project, archaeology, through what Esri calls the hub, And the hub is really a centralized, organized area of information that allows users and collaborators to contribute to a project centered around an initiative. So it really takes that approach of an initiative, encouraging collaborators and the public to provide information, to learn and contribute information to that site. So another item that I want to focus on is dashboards. Dashboards are configurable web apps that display interactive information such as graphs, charts, and maps on a single screen. Dashboards can be configured to support operational monitoring and decision-making or tailored to a specific audience. I intend to create dashboards for the content submitter and reviewer reporter. With a dashboard, each user can visualize and track information about thefts and reports. But that information is customized to their specific interests in the data. This image is an example of a similar type of dashboard created for Global Explorer, which is a crowdsourced project for evaluating satellite images to identify looting of archaeological sites. While this isn't an example of an ArcGIS dashboard, it demonstrates how dashboards can be effective interfaces for users to track their progress and encourage ongoing participation. And I did mention that an operations dashboard can be deployed as well. So time permitting, I think that would be a good thing to do as well for the host organization. And the host organization and collaborators will have the ability to analyze data. The types of analysis may be spatial, such as hotspots, risk analysis, distance traveled, and temporal, such as frequency thefts and sightings, timeframes for when things occur, such as seasonality, and time to recover the artifacts. And insights for ArcGIS is what Esri calls a workbench. It's available in ArcGIS Online, and you can bring data together to perform visual analysis. The user creates a workbook and can drag and drop data into analysis workflows and create multiple cards for displaying analysis results. This tool would be used by the organizational users to analyze the data and prepare results. This can be used by the organization in the future as data is enriched by the application user. So there are challenges and limitations to my work. The first, and I feel this is important, is that I do lack institutional knowledge. Archaeology is not an area of expertise for me. It's an area of interest. So my next step is to seek participants, look for subject matter experts, people who are involved in the institution of archaeology and the profession to hopefully participate in vetting and testing the solution. And I think that that's going to be very important for helping to guide the outcome of the web applications. ArcGIS Web App Builder does have limitations. I do expect that I will probably encounter some of these. It is really, Web App Builder is really centered around customizing using widgets, which are really pre-configured mini applications, I guess, that you can incorporate into your application and configure the overall application the way that you want it to look and feel and how you want it to perform. There are many widgets available, but in order for the applications to do or precisely what I want them to do, I may need to use additional tools and some development may be required. I am trying to take a low development approach with this, but ArcGIS App Studio and ArcGIS Web App Builder Developer Edition are available if you encounter those limitations. And it's also not solving the problem of the lack of linkages between research and TEP databases. It's really providing an alternate solution. So this may not satisfy all needs, but this solution is centered around collaboration and public engagement. So as an alternative solution, I think it does answer some of those questions from the literature review. My anticipated results are to have a functioning prototype WebGIS solution that engages collaborators and the public, and to demonstrate how a WebGIS platform can be used to apply spatial methods to encourage broad participation in the pursuit of artifact recovery. This is my general timeline. As I mentioned, my next step is to seek out subject matter experts, professionals that may be able to participate. I really think that that's going to be very valuable help. I do over the spring, winter and springtime, I'll be working on the database design and building and testing components. And then in the summer and fall, I'll be finalizing my work and presenting in some possible venues. I've considered geography and GIS venues and archaeology-oriented venues. So I'll be hopefully applying to several and narrowing it down. But some that I've considered are the Esri User Conference, GIS Pro, and the Applied Geography Conference. Also, based on what I've seen out there for archaeology-related conferences, there are a few happening in the spring. It's beyond the paper submission at this point for those, so I'm targeting some that may be happening in the fall. Great Basin Anthropological Conference has archaeology components to it, and also the National Congress of American Indian Conference. Looks like it's a good one as well, happening in October. And I will be continuing to look for some other conferences that may hold promise as well. And these are my references. My presentation. Do you have any questions?
Well, great job, Karen. Have some questions hopefully for you.
Do you have an idea about how you'll generalize archaeological sites? From Neil Rose. Yes, so Dina does a generalized grid over a cell-centered area. So it's an approach that I could potentially replicate or use from Dina that it is open and useful, so you can bring some of that information in. Yeah, you can definitely pick a broader area and have a generalized cell over a region. So I've thought a little bit about that. And the second question from David, are you aware of any progress in computer vision techniques to help identify stolen artifacts with particular native cultures and their geographic locations? Thinking about Planet, Snap, and iNaturalist or floral species identification. Yeah, the only ones that I have noticed have been some of the pattern recognition. So yeah, I have not looked into that for this effort, but that would really be a nice add-on if that could be something that could be incorporated. I can certainly look more into those. Thank you. Okay, and Neil has another question for the web application. Are you looking to deploy user logins for site access or utilizing anonymous access and editing? So, yeah, I have not decided that yet. I certainly have thought about it. I think that there are people who would want to stay anonymous, but I prefer to have a site login. I think with the application and with the hub, it would be good to, for at least the application users, to have that login, especially if there's a need to contact that user for information that's been submitted and to monitor and vet the information that is being submitted. But I do think that some users may want to remain anonymous, so that could be an option as far as setting up the application if it would just be readily accessible or using a login. Can the same method be applied to pawn shops and stolen goods in the United States? From John. Do you fear retribution from thieves? I certainly think that people could, and I do think that this method, the organization that I envision for this method would be more of an organization that would have resources that can respond to the thefts potentially. And I'm thinking of land management or state archaeologists, some type of public organization that would be able to either have access or collaborate with enforcement. So at least from my approach, I would not be concerned about retribution, but certainly that is always a risk when it comes to turning in information about something that somebody has and they shouldn't. As far as applying it to pawn shops and stolen goods in the United States, yeah, I think that that's definitely, that can be a user as well. I mentioned that the Interpol and FBI, a lot of those users are people involved in the trade. So that can be people in pawn shops, that can be specific traders in collectible items. And that certainly can be extended to involving those people as well. Fritz, this is tangential, but is ground penetrating radar utilized in any capacity to find and locate artifacts? Would this technology be useful in your research at all? I am not considering ground penetrating or any other sensor information in my solution. However, I have thought about that as an item that could be understood or information provided about those specific artifacts. I think that, and also how I've thought about it, is that archaeological sites and those managing those sites are using those technologies to find and start inventorying artifacts that are in the site or in situ, in the ground, as they're being measured. So I think that is an extremely important technology, and I think that can potentially expedite the search and recovery because of understanding what's in the site. One of the biggest problems is when the sites are looted, they have not been inventoried, and so there is no tie back to the site to understand. And you do lose that scientific in context, that scientific value immediately because there's no way to tie it back to the site. Looters don't take the time to be careful about the surroundings. So where it's at, where it was found, in what context it was found, that really is destroyed. So I think that ground penetrating LiDAR or radar and LiDAR for canopy removal, that sort of thing, is very valuable and certainly can be used by the site managers and the collection managers to know what's in the ground, know what's in the site, and be able to tie it back specifically to that in situ location.
All right. Well, thank you, Karen. That was a very interesting idea. So I'd like to take this opportunity to thank all of our presenters and their wonderful topic ideas and the presentations, all very, very interesting. So we'll look forward to hearing from them at some point in the future for their 596B capstone presentations. So I do want to mention that make sure to fill out the peer review evaluations for all the presenters in this section of 596A. Also remember, we have 2 more 596A presentations coming up next week. One is Tuesday, October 20th from 10:30 to 1:30, and then Wednesday, October 21st from 6:30 p.m. to 9 p.m. And Beth just looked or posted the link to the peer review website, so make sure to visit that. And with that, I will wish everybody a good day and thank you for participating.